Often it takes a time of crisis to put those jobs we all know we should be doing back at the top of the agenda. One of the things that we are seeing and hearing is that companies are looking at mapping their supply chains and investigating alternative suppliers for their key products and services. Many companies are considering suppliers closer to home, either reshoring or nearshoring, and whilst we agree that mapping the supply chain is an important exercise, there is an awful lot more to it than this, and in many cases, when it comes to an actual move, it is not panning out as smooth or as easy as anticipated. Many of you will be aware that we have been sharing our journey to manufacturing excellence. But at this time of COVID-19 and the period of reflection that it has brought about, we thought that we would pool our knowledge and put together something for you, a series of exercises and practical things you can use to guide you in assessing your readiness to move your supply chain should you want, or worse, need to. This breaks down into 4 sections: IP, data accuracy, obsolescence, and regulatory. First is IP, and the key question: do you have all the IP for your product, from a comprehensive bill of materials and schematics to labelling, artwork and test procedures? Plus, if your product is testing using any bespoke test equipment, do you also have the IP for that equipment and/or ownership of that equipment? Often when reviewing a product, we'll come across a sub-assembly, bespoke part, bit of firmware or a test procedure that has been outsourced somewhere down the line, and not always by the OEM. This can be difficult to identify at first glance. It is worth the time to find out, because this can be one of the pitfalls of moving and could therefore put your whole supply chain at risk. If you think that this could be the case for you, in fact, I would go so far as to say, if you're 99% sure that this isn't you, I would encourage you to ask yourself the following questions. First one: can you identify the suppliers of all the bespoke parts within your product? Do you have the contact details, and do you know how they identify the part in question? Do they have a unique number for it? Perhaps you could go on to establish if you could still purchase this part should your primary supplier no longer be in existence. What happens to one of those bespoke suppliers? Do you know who owns the IP of each bespoke part or process? If you've paid for the development and are now the IP owners, you'll need to make sure that you have all the original design information, CAD data, library files, etc., sufficient that you could move the product or make modifications to the design if you needed to. An output from a CAD file, such as a Gerber file, will not be sufficient for future-proofing. Other areas to watch out for under the banner of IP are bespoke test boxes, firmware and software. If a test box has been developed specifically for your product or product range, do you have all the design files as mentioned previously? Could this unit be duplicated and moved to a new supplier if capacity or move dictated? All of the above also applies to tooling, as well as if you've invested in production mould tools. Do you own them? Do you know where they are? Can you move them if you need to? The second thing to look at is data accuracy. Now you have all the data, does it all tie up and does it make sense? You would be shocked how often we are sent data that doesn't match the sample unit, bill of materials that only contain the incumbent supplier's internal part numbers, or have part numbers that don't match the parts on the board. I could go on, but I'm sure you get the point. So for this next exercise, you'll need a sample unit, all your data and a little bit of time. Start sub-assembly by sub-assembly and do a comparison between your CAD data and your sample, asking the following questions. So with regard to the PCBs, does the issue status printed on the PCB match the CAD data? Does the resist and ident colour, board thickness, finish and size match the drill and profile drawing information? Are there any obvious modifications on the board, and if so, are these documented anywhere? Can you establish what the new or additional parts are, and have they been added to the bill of materials? When you're looking at enclosures, bespoke packaging and labels, do your mechanical drawings match your samples? Are all the holes, materials, finishes, sizes, artworks, etc. as per the drawing? And if not, which one is wrong? Is it the drawing or is it the sample? Cable assemblies. Do your cable assemblies conform to your drawings? You may even want to consider buzzing these out if you are in any way unsure. Can you identify any tooling or crimp tools that would also be required? box build assembly. In our experience, this area of the design often carries the biggest risk and has the poorest quality data. There is usually a bill of materials, a set of bespoke piece part drawings, an exploded assembly drawing, and sometimes a set of assembly instructions. The challenge with this level of the design is that it is somewhat trial and error and often results in changes to the supporting documents as the assembly process develops, and that's where the problems begin. On a lot more than one occasion, we have received BOMs with an exploded drawing and or work instructions where we have been unable to easily tie the items on the BOM to the drawing, or the quantities do not tie up. The documents may have become unsynced, with item 10 on the drawing calling up a screw. When we refer to the parts list to confirm which screw, it is actually listed as a cable. This happens a lot. Again, this activity takes a little bit of time, but sit down with your sample, your parts list and drawings, and go through the parts list line by line and tie it back to your drawings, assembly instructions and a sample, asking yourself the following questions. Can you tie the drawing assembly instructions to the bill of materials and identify which part is which? Does the part shown on the drawing and the sample match as expected from the parts list? Is the quantity called up correct when compared to the assembly instructions or CAD drawings? Are all the items on the assembly instruction called up on the parts list and vice versa, or do you have items that are left over? Is it clear where the as required items, such as Loctite, should be used? Are there any extra parts on the build, such as washers, that aren't included on the bill of materials or the assembly documentation? If it is a complicated build, is it clear in what order the product should go together? Does the physical wiring of the unit match the drawings? And is there any tooling that would be required to facilitate the build? Testing. Are you clear on all the test stages of the product build? Are there written work instructions for each stage? Is it clear what test equipment should be used? Would you be able to purchase, or referring to our IP section earlier, would you be able to recreate any bespoke test equipment? Do you have supplementary work instructions explaining how to set up all the test equipment ready to run the procedures? How are the test results recorded and archived? Are the test limits or pass-fail criteria specified? Are you aware of any common test failures and how to rectify them? Labelling. Do you have all the artwork for the labelling? If the labelling needs to conform to any regulatory requirements, have the label materials, adhesives, windows, apertures and finishes been specified? The third section and exercises are around obsolescence. Obsolescence is an ongoing problem within the electronics industry, compounded by the speed at which parts are obsoleted and replaced. Whilst we all deal with these problems on an ongoing basis, documenting them with the original design information is less common, particularly if you use the services of an external design house, which, for the record, are on the whole amazing, but unless you have defined who will be documenting any agreed changes within the original design data each time you pass them a question from your suppliers, and you ensure you receive a copy of the updated information back again, then you should probably assume that they have just answered the question that you have asked of them. You can probably get a bit of a feel for the risk in this area by asking just two questions. First one, how long has your product been in manufacture within its current supply chain? And do you have a robust set of procedures in place to document alternative parts as you agree them with your supply chain? If your answer to question 1 is 1 year or less, then you can probably rest assured that it is likely that you have or will have been made aware of all the information needed to be able to move your supply chain. If your answer to question B is a confident yes, then again, I'd sleep easy and that there will be no surprises leaking out of this camp. If, however, you've been manufacturing with your current supply chain for longer than a year and you don't have robust procedures for recording obsolescence replacements as you agree them, then you could have a significant problem, and an immediate action for the top of your to-do list, we would recommend asking for a copy of your supplier's manufacturing bill of materials, including manufacturer and manufacturer part number information. We have, on numerous cases, been asked to look at BOMs that include descriptions and internal part numbers only. For obvious reasons, these are no good to anyone, and if that's all you are able to get access to, then you have some work to do now in case a link in your supply chain breaks. Your next exercise is to go online to the component catalogues and source each part and establish your component availability or obsolescence position. Depending on your volume, this may or may not be competitive sourcing solution, but that's not what we're looking for at this point. All we need is component status and availability. Having said that, these guys are becoming increasingly competitive, so don't rule them out. You'll then have a number of parts left over that you aren't able to source through these channels, so you will have to look at those individually. After that, identify your single source parts and establish if you have everything that you need in place to minimise the risk of delays should one of those parts increase in their delivery schedule. Your final exercise, regulatory. What do your regulatory requirements look like? Are you allowed to make certain changes to your suppliers if you need to? Would you need to inform your regulators if you've made a change to your supply chain? And are you clear on what regulatory standards a new supplier would need to have in place? Our regulatory environments are changing all of the time, and I'm sure that if you are in an industry where the rules are particularly strict, you will be aware and will have within your team a quality representative of some sort. For this last exercise, I would suggest that you have a coffee with that person and discuss the project with them. If you don't have any such person or are unsure of your responsibilities, find yourself a notified body and start a dialogue with them. I cannot recommend enough the value of doing these exercises, particularly for older products. You may not like the outcome, but either way, at least you will understand the risk to your key products. To support this video, we have created a free of charge risk review document that you or your team can work through. So if you'd like to get your hands on a copy, please do get in touch or follow the link below.